Welcome to SND College of Engineering, Yau. In today's lecture, we will discuss some example on half-range Fourier sine series. Here the first example is find half-range sine series for the function f of x is equal to x into pi minus x, and the function is to be defined in the interval 0 to pi. To find the solution, first we write the given function f of x is equal to x in bracket pi minus x, and the function is to be defined in the interval 0 to pi. We know that in half-range sine series, the value of the Fourier coefficient a0 and an are always 0. Now we find the Fourier coefficient, which is bn is equal to 2 pi integral 0 to pi f of x sin nx dx. Now in next step, we substitute the function f of x. So we get bn is equal to 2 pi integral 0 to pi x into pi minus x into sin nx. So before find the integration, we first multiply x into this bracket. So the next step is bn is equal to 2 pi integral 0 to pi. By multiplying x in the bracket, the function becomes pi x minus x square sin nx. So again, by applying the formula here, so we get the integration of the function. So the 2 pi in bracket pi minus x square into minus cos nx divided by f minus the derivative of the polynomial here pi minus 2x, and the integration of the function here minus sin nx upon n square. Again we differentiate polynomial again, which is minus 2, and we take the integration of this function cos nx upon n cube. So here the limits we apply 0 to pi. So by applying the limits 0 to pi, so what we get here, see this one, by applying the limits we get this step. So after we know the value of the here pi minus pi square, which becomes 0, right? Here the value of pi minus 2 pi is minus pi, but the sin n pi is become 0, and here the cos n pi as it is, minus 2 as it is, and divided by n cube as it is. Here also 0, here the value sin 0 is 0, and here cos 0 is 1, so the remaining minus 2 upon 1 upon n cube. So the next step here, value of minus 2 cos n pi is minus 1 raised to n divided by n cube, and here the terms we write here as it is. So by simplification we get the value of bn as 4 upon pi into n cube in bracket 1 minus 1 raised to n. So we know the Fourier series representation, half-range Fourier sine series representation of the function f of x is equal to summation n runs from 1 to infinity bn into sin nx. So f of x is equal to summation n runs from 1 to infinity 4 by pi into n cube 1 minus minus 1 raised to n sin nx. So here 1 4 by pi, which is a constant, we take outside the summation. So the final Fourier half range sine series, which is represented by 4 by pi summation n runs from 1 to infinity 1 upon n cube in bracket 1 minus minus 1 raised to n into sin nx, which is our required solution or required Fourier series expansion of the given function. Next, here also we find the half range sine series, but which is for the arbitrary interval, that is the interval is of the form 0 to L. The function is to be given to find the half range sine series, which is f of x is equal to x square. So to find the solution, first we consider the given function f of x is equal to x square as, and the interval is 0 to 1. We know that in the Fourier's half range sine series, the Fourier coefficient a0 and an are always 0. Now we find the value of L by comparing the intervals, given interval 0 to 1 with arbitrary interval 0 to L. So we get the value of L as 0 to 1. So Bn, we write the formula for the Fourier coefficient. Bn is equal to 2 by L integral 0 to L f of x sine n pi x upon L dx. We substitute the value of the function as a x square, and I solve the integral 2 by 2 integral 0 to 1 x square sine n pi x dx. Here to find the integration, we use this formula, integration u into v dx. The formula is to be mentioned. Next, by applying the formula polynomial into function, so we get the integration. So Bn is equal to 2 in bracket x square minus cos n pi x upon n pi minus the derivative of the polynomial, which is 2x, and the integration is of the function is minus sin n pi x upon n square pi square. Again we differentiate 2x in next term to write the next term, which is 2, and again integrating the function, so we get cos n pi x upon n cube pi cube. So we apply the limits 0 to 1. In next step, we apply the limits, upper limit as a 1 and lower limit as a 0. By applying the limits, so the value here minus, here the minus sign as it is, 1 square is 1, cos n pi is minus 1 raised to n divided by n pi. We know the value of sin n pi, which is 0. Here the value of cos n pi is minus 1 raised to n divided by n cube pi cube into 2 minus, here the cos, here the 0 is multiplied, so the 0 which becomes 0, here also 0. Here the value of cos n pi is 1, 2 as it is, n cube pi cube. So by simplification, we get the terms Bn is equal to minus 2 minus 1 raised to n upon n pi plus 4 upon n cube pi cube into minus 1 raised to n upon minus 1 raised to n minus 1. So first we write here the Fourier's sine series expansion. So the summation n runs from 1 to infinity Bn sine n pi x upon L. We substitute the value of L as well as the Fourier coefficient Bn. So we got the Fourier's half range sine series. Thank you.